Hi everyone, welcome to my channel Ravi Babu Edu Tech. Today we are going to cover rectifier efficiency and ripple factor. Okay, in that rectifier efficiency, let's calculate. So rectifier efficiency is denoted as symbol of eta. Now what is rectifier efficiency? Generally what is efficiency? Efficiency is nothing but to get output by input ratio. That is called efficiency. Okay, the output of the voltage or current or in terms of power. You can calculate anything. Output voltage by input voltage as well as output current by input current and as well as output power by input power. So based on the formulas you can able to find out. Now in this case we are going to calculate full wave rectifier, whereas in half wave rectifier how much efficiency you got? 40.6%. So this is very poor efficiency in the case of half wave rectifier. So that we need to improve the rectification efficiency so that we might use it as two diodes. With the help of two diodes it can be rectified continuously. For that purpose only we are increasing efficiency. How it is getting value we will see now. Now what is rectifier efficiency is nothing but it is defined as the ratio of the DC output power to the AC input power. That is what rectifier efficiency, that can be given as eta equal to DC output power upon AC input power. Okay, now this can be written as what is DC output power in the sense that is PDC by PAC, where PDC is nothing but DC output power, where PAC is nothing but AC input power. Okay, right. Now let's calculate. Before we need to find out efficiency in the sense, let us find out what is PDC and PAC. Okay, let's find out PDC first. See here, power should be calculated in the sense you might know very well about power value formula. That is power equal to what? I square into R times. Okay, power is equal to I square into R times. So in that case here we are going to calculate what? At the load resistance. In this load resistance what is my power? Okay, here IDC and as well as drop across load resistance VDC. So in that case we may calculate power value. So now this can be written as IDC square into RL. Okay, this is what expression for the PDC. Now let's simplify. So IDC is nothing but what? VDC by RL whole square into RL. That equal to, this can be written as VDC square divided by RL square into RL. Okay, so RL square one time get cancelled, that is VDC square by RL. Now let's calculate. Since what is VDC value already we had calculated, that is 2 Vm by pi. Okay, VDC is equal to 2 Vm by pi. Now substitute in that place 2 Vm by pi whole square divided by, that is 1 by RL. Okay, 2 Vm by pi whole square into 1 by RL. That equal to 4 into Vm square by pi square into RL. That is what? PDC. Hope you understand. Okay, so PDC is equal to I square into IDC into RL. Simply according to Ohm's law you should substitute here. Then by simplification you will get it finally this expression. So 4 Vm square by pi square into RL. Now let's calculate PAC. So PAC is nothing but Again, very simple, according to Ohm's law, I square RMS into RL, that equal to, what is I square? I is nothing but what? V by RL, that is VRMS divided by RL whole square into RL, that equal to, what is the expression? It is VRMS whole square, that is V square RMS by RL square into RL. This one get cancelled. That is what is the expression remaining? V square RMS by RL, that equal to, let's calculate now. So what is VRMS here? VRMS divided by, that is equal to Vm by root 2. So VRMS is nothing but Vm by root 2. Now substitute here Vm by root 2 whole square into 1 by RL, that equal to Vm square divided by root 2 whole square, means that is square root get cancelled into RL. So that is what expression for PAC, that equal to Vm square divided by 2 RL. Now we got value of PDC as well as PAC. Let's calculate efficiency. So efficiency is nothing but PDC by PAC, that equal to, what is the efficiency value? PDC value. This is the expression 4 Vm square by pi square RL. Okay, 4 Vm square by pi square RL. Okay, divided by, what is PDC? This is the expression Vm square by 2 RL. So now Vm square get cancelled, RL get cancelled, then remaining, what are the remaining things? So these two get into the above 4, that is 2 into 4 divided by pi square, that equal to 8 by pi square. Okay, so now eta equal to 8 by pi square in the sense 0.812, that is exactly 81.2%. Okay, so that is the expression for full wave rectifier. So because of full wave rectifier in used as 2 diodes, then it rectified continuously, so that because of that reason we might increase as efficiency. Now comparing this half wave rectifier, full wave rectifier is very high efficiency. Okay, so this is what rectifier efficiency. Let's calculate ripple factor. Then what is ripple factor generally? What is ripples? Ripples in the sense, in the case of half wave rectifier, ripple factor value is 1.21, and here in full wave rectifier we are going to find out. So ripple factor 1.21 in the sense, after rectification, what is the signal we are getting? Pulsating signal. Okay, so this is what pulsating signal. This is, it's not a desired output for DC. So we need to remove this kind of pulse, then only we can improve the efficiency as well as to reduce the ripple factor, ripples of the AC components. Okay, so for that purpose, now what we're going to find out? Ripple factor. What's the presence of amount of AC in the output? Okay, now generally ripple factor is denoted as R, that equal to RMS value of the AC components divided by average value of the DC components. So this is for AC components, that is VR RMS divided by VDC. So this is the expression for ripple factor. Now this can be written as, we need to find out this R equal to VR RMS divided by VDC is nothing but, let's calculate first VR RMS. So VR RMS equal to square root of Vrms square minus VDC square. So this is the general expression for VRMS value. Now how to simplify this expression in the sense, so VRMS is equal to, according to my convenience, I am going to simplify this expression. V square RMS minus this VDC square get into the outside, that is 1. If you take it as outside in the sense, what will happen? Here we will get VDC square minus 1 into VDC square. Hope you understand. If you multiply this term in this inside, so VDC square into 1, that is VDC square, into VDC square into VRMS square divided by VDC square. Okay, so VDC square get cancelled, then VDC square, that is what? Above step. If you multiply this expression, cancellation will occur, you will get above step. Like that I am taking outside of this VDC square. Okay, now after that, this is including VDC square. Now if you take outside, VRMS divided by VDC whole square minus 1 into VDC. So VDC square root get cancelled. That is the expression for VRMS. Now substitute this value in that expression. Okay. Now ripple factor equal to VRMS by, what is the expression? That is VDC. That equal to, so what is VRMS value? Square root of VRMS divided by VDC whole square minus 1 into VDC divided by this VDC. So VDC get cancelled. So ripple factor equal to square root of VRMS divided by VDC whole square minus 1. So this is for general formula to calculate ripple factor value, whereas in half wave rectifier and full wave rectifier. Okay. Now let's calculate. First one is in full wave rectifier. We are going to calculate what is what is ripple factor for full wave rectifier. So with help of this expression. So R equal to square root of VRMS square divided by VDC square minus 1. So as you know, what is VRMS in full wave rectifier? That is Vm by root 2. What is VDC? 2 Vm by pi. Hope you understand. Now with help of this expression you have to substitute here. So VRMS is nothing but Vm by root 2 whole square divided by 2 Vm by pi whole square minus 1. That equal to Vm square divided by, so root 2 square is nothing but get cancelled, that is 2, you will get it by 4 because it is 2 Vm by pi whole square now. So 2 whole 4 into Vm square divided by pi square minus 1. Here Vm square get cancelled. Then is there any other calculation? No. So this pi square get into the numerator. So this pi square get into the numerator, that is pi square. Then here 2, that will get 8. Okay. So that is the value of this expression. So if you simplify this expression, you will get it 1.21. By using this calculator, pi square is nothing but, let me show here. So 9.8596, that is the pi square value, because of pi is equal to what? 3.14. So 3.14 whole square is nothing but 9.8596 divided by 8. If you substitute the square root, you will get approximately ripple factor equal to 1.21. So ripple factor equal to 0.48. Okay, sorry for the inconvenience. So if you simplify this expression, you will get ripple factor equal to 0.48 for full wave rectifier. Okay, now in full wave rectifier is very much of ripple factor is reduces comparing half wave rectifier. Okay, so now this is the expression for the full wave rectifier. So thank you for watching my video.